So, dear learners, today my lecture will be entitled with Electrical Induction Motor, and myself, Dr. Vikramaditya Dave, will be teaching you about the electrical induction motor. So, after attending this session, you will able to know about the following things about induction motor. First of all, we will classify AC machine. Secondly, we will deal with the construction of induction motor. Thirdly, we'll talk about the basic principle of working of induction motor. You will also come to know about the concept of slip, and lastly we will do a numerical to do analysis of an induction motor. So that will be a basic numerical problem. So you know that in a AC, in electrical technology, there are two types of supply as the AC and DC, and according the machines are also being classified as AC and DC machines. Here we will classify AC machines. The AC machines are classified as synchronous machine and asynchronous machine. The asynchronous machines are also known as induction machine. Now these machines are of also two types, that is generator and motor. So each and every AC machine is also classified as a generator and motor. For example, synchronous generator, synchronous motor, and on the induction side we have an induction generator, induction motor. Further, there is a classification of supply as a single phase and three phase. So we have an C phase, three phase generator and three phase motor. Similarly, single phase generator and single phase motor. And thereby, if we classify asynchronous machine, we will have a three phase induction motor and three phase induction generator, and a single phase induction generator and a three phase and single phase induction motor. Now let's come to the construction of induction motor. Now every rotating electrical machine has four parts. Stator, the stationary part, its corresponding winding called stator winding, the rotor, the moving part or rotating part, and this corresponding winding called rotor winding. As from figure you can see there is a outside frame is there, that is called stator, and inside this stator there are slots are there on its inner periphery, and in these slots are accommodate the second point, that is stator windings. You can see these are the windings. Now we are talking about the three phase winding, so there are three phase windings are being accommodated in these slots. The second, sorry, the third part is the rotor, which is connected to the shaft, and this rotor have slots on its outer periphery. Okay, so and in these slots is accommodated the so-called rotor windings. Okay, the small circle are representing the rotor windings. Now you will surprised to know that in case of induction motor, instead of using winding, we have a rotor bars which are made up of aluminum and copper. So these bars are being placed and they are being short circuited at the ends, and we have a two copper end rings. So in case of induction motor, the so-called rotor winding or rotor bars are in short circuit condition. This point to be noted. Now after going through the construction, let's comes to the principle of working on induction motor. As in case of transformer, the principles of electromagnetic induction, here also it is electromagnetic induction principle is there, where as soon as you give a supply to the stator winding produces a rotating magnetic flux. Now this rotating magnetic flux cut the rotor bars or rotor windings, and being short circuited in nature, an EMF is produced and also an induced current is produced. Now this induced current will also produce an flux, and this flux will interact with the rotating magnetic flux, and thereby a torque is generated and the motor starts rotating. Now one important point to note, students, that there are two speeds are there. One, the rotating magnetic field speed, and another is the speed of the rotor, or also called it the speed of the motor. Both are different. The rotating magnetic field speed is called synchronous speed and is given by ns is equal to 120 f upon p, and the speed of the motor or rotor is different from that of the so-called the synchronous speed or rotating magnetic field speed. So there comes a concept of slip. The slip is nothing but a concept introduced to accommodate the difference in the speed of the synchronous and the motor speed, and mathematically it is defined as the difference between synchronous speed and the motor speed with respect to the synchronous speed. And if you want to express in percentage, get multiply this formula by 100, you will get the percentage slip. So we will understand this slip concept through an numerical. Now slip can be positive and negative. When it is positive, when in negative, we will discuss in the next class. But for the time being, let us take a numerical. A 6-pole 3-phase induction motor is running at 1170 rpm. RPM spent or revolution per minute. The supply frequency is 50 Hz. Calculate the percentage slip. Now the first step is that you will calculate the synchronous speed, which is given by the formula 120 F upon P, where F is the frequency of supply. Here we will replace F by 50 and poles by 6. We will get the synchronous speed to be 1000 rpm. But the actual motor speed, that is the rotor speed, is given 1170 rpm. So if I find out the difference of synchronous speed and rotor speed, comes out to minus 170 rpm. So you need not have to worry when it will be positive, negative. We'll discuss in the next slide. But at present it is minus 170. So we will place in this formula of the slip, and we'll get 170 upon 1000 into 100. It will comes out to be 17%. Okay, so the percentage of slip of motor is basically minus 17%. Okay, so this is the all through this numerical you have gained the concept of the slip. So, students, I hope you have grasped all the fundamentals which I have taught in this slides, and you have learnt about following things: the classification of AC machine, construction of induction motor, also the principle of operation induction motor, and you have also gone through the concept of slip, and that also through a numerical problem. So, thank you for your attention and bearing patience. We'll meet in the next class. Thank you.